All right, what up, everybody? Today we're talking about total resistance. Remember, resistance is a measure of how much a part of a circuit pushes back against the current. Right? If something has very low resistance, then there are a lot of current can flow through that area. But if there is a lot of resistance, then only a little bit of current can flow. So, in a series circuit, we've already learned that you just add up the resistances of the different components. So let's say if there's 3 light bulbs in your series circuit, you would just add up the resistance of each light bulb, and that gives you the total resistance. However, it's more complicated when you have a parallel circuit. So you can see at the bottom of the screen here, the equation for resistors are in parallel. So if you have a circuit that has 3 different resistors, then you'd have to use this equation here to find the total resistance, which would be this variable here. If you had 2, you just use R1 and R2. If you had 4 different resistors, you'd have to add like a 1 over R2 to the equation. So as many resistors as you have, that's how many terms you have on the right side. All right. And so here's a series circuit. Now those squiggly lines that we have here represent some type of resistor. Probably the most common one is a light bulb, at least in the labs that we do. But resistors could be anything that you plug into a circuit that does not let the current flow freely to it. So if you had like a hair dryer in a circuit, the hair dryer would be the resistor, or a speaker, the speaker would be the resistor. Okay, so in this series circuit, you have 2 9-ohm resistors. Because it's a series circuit, you can just add them like normal. 9 plus 9 is 18. So the total resistance of this circuit is 18 ohms, right? And that would determine how much current would flow through that. Right, here's another example, but this time we added a 3rd resistor, and let's see what that does to the total resistance. If you add it up, you get 27 ohms of resistance. So adding the extra resistor actually increased the total resistance, and that's always the case with series circuits, right? And because there's more resistance in this circuit, you'd have less current flowing, and so if these were light bulbs, you'd have dimmer light bulbs. Now let's look at a parallel circuit. So here's a parallel circuit, and just like the last circuit we saw, it has 2 9-ohm light bulbs. But because they're in parallel, we add up the resistances in a different way. We use this equation, right? And so 1 over 9 plus 1 over 9 would be 2 over 9. We haven't found the total resistance yet because you notice that the equation has RT, the total resistance, on the bottom of this fraction and 1 on the top. So we could flip this fraction over, and we have to flip the fraction over on the other side, and that gives us RT equals 9 over 2. Okay, so when you're finding the total resistance in a parallel circuit, you always have to flip it over at the end. So 9 over 2 would be 4.5 ohms, which is interesting because both resistors are larger than 4.5, but put together, their total resistance is only 4.5. You can think of this like if you're in a supermarket and a lot of people are trying to get out the store, but there's cashiers, and the cashiers will slow down people because they make them put their food on the conveyor belt and pay for their food. Right? So the cashiers slow down people. However, if you open up a second cashier, you actually speed up the flow of people out the store because you added an extra path for people to go through. So even though resistors slow down the flow of the current, adding them in parallel means you're giving more paths for electricity to flow, so you actually decrease the total resistance. All right, so let's see what happens when we add a 3rd resistor in parallel. Do the math. 1 plus 9 plus 1 plus 9 plus 1 plus 9 is 3 over 9, which you flip over, and that would be 9 over 3, or 3 ohms. So by adding the 3rd resistor in parallel, we actually decreased the total resistance even more, down to 3 ohms. So more electrical current would come out of the battery itself because there's less total resistance. Now, not all circuits are series or parallel. There's also something called complex circuits, where there are uh, parallel parts and series parts to the same circuit. So, how do you find the total resistance in those? Here's an example. Right, you can see it kind of looks like a parallel circuit, except some of the branches have more than one, um, more than one resistor. So the way you would do this is you would simplify the circuit so it was either one way or the other. So either simplify it to be a series circuit or simplify it to be a parallel circuit. And it looks like this will be easier to simplify and make a parallel circuit. And the way I do that is for each branch, I'll just add these up. So these two 5 ohm resistors in this branch are equivalent to one 10 ohm resistor. And then these three 5 ohm resistors in this branch are equivalent to a 15 ohm resistor. All right, so then I would just solve this for the total resistance in this circuit right here. So we'll do that. Here's the equation for a parallel circuit. All right, this time the math is going to be a little more complicated just because we have different denominators. And remember, when you do that, you have to find a common denominator, in this case 30. So 1 over 5 is the same thing as 6 over 30. How do I find that? You just, whatever number you have to multiply the bottom by, that's what you have to multiply the top by as well. So multiply the bottom by 6 to get 30. You have to multiply 1 times 6 as well. All right, 1 over 30 becomes 1 over 10 becomes 3 over 30. 1 over 15 becomes 2 over 30. And then you add those together, and careful, you add the tops, not the bottoms. And that gives you 11 over 30. You flip that over, 30 over 11, or 2.7 ohms, and that's rounded a little bit. Okay, so the total resistance for that whole circuit that we saw in the beginning is 2.7 ohms. Here's another example, and this time it's going to be easier to combine these two parallel resistors and make them into one, and then treat the circuit like a series circuit. Okay, so adding these two together, you have to add them in the parallel way. 1 over 20 plus 1 over 60, we'll have to change the denominators to be both 60. All right, so you multiply this one by 3, so you can get 60 on the bottom. 3 over 60 plus 1 over 60 is 4 over 60. Flip that over, you get 60 over 4, which would be 15. All right, so we'll redraw this circuit to look like a series circuit where you still have your 10 ohm resistor, but we'll replace these two resistors by their equivalent resistance, which is 15. That allows us to add these in series, which is easy, and get a total resistance of 25 ohms. All right. All right, have a great day. I'll see you all.